So let's take a look at doing static routes in a dual stack environment. So here's our packet tracer. You can see we've documented the IPv4 and IPv6 addresses for all of our networks, and then we've also documented the interface IDs and host addresses for v4 and v6. Now, if you want to follow along, you can download this file. If you have Packet Tracer, download the file. It's linked in the description below. You can open it up and you can follow along. If you do so, your console password is documented up here. Console password is Cisco. Privileged exec mode password is class. Now, as you recall, a router will automatically add directly connected networks into its routing table. So from R1's perspective, this network and this network are directly connected. So it's going to add in these two IPv4 networks and these two IPv6 networks into its routing tables automatically. But since it's not directly connected to this network or this network, it's not going to know about these IPv4 and v6 networks, so it won't add those to the routing table. So we can either configure a routing protocol or we can set up static routing. Now, since we're demoing static routing, we're going to do it that way. So let's start with v4, and we will need to configure a static route for this network and this network. So I'm going to open up R1, and let's make this a little bit bigger. Give us a little bit of a look at our network map here. Writing static routes is much easier when you have a good network map in place. So there's a couple of different ways that we can do static routes. We're going to start by writing next hop static routes. So the way we're going to do this, we're going to go to global config mode. And then the command to create a static route is IP route. So we're going to IP route, and then we're going to set our destination network ID. Now, most of the time, not all the time, most of the time, you're going to write static routes to networks, not hosts. So that means you're going to need to specify the destination network ID and subnet mask. And this is 192.168.0.4/30. So we're going to IP route 192.168.0.4 and /30 is 255.255.255.252. Now this is going to be a next hop static route, which means we're going to specify the IP address of the next hop that's going to get us there. And that's going to be this right here, 192.168.0.2, because we're going to forward it to there. That'll be our next hop, and we'll let him take it from there. So we're going to specify here 192.168.0.2. And that will get us a static route to this network. Now, I also want to write a static route to this network, which is going to get me to my ultimate device. So I need to put that static route in as well, and that's going to be 192.168.11.0/24. So my command is IP route 192.168.11.0/24 is 255.255.255.0. Reference back to my network map. I want to get here, which means I've got to go this route, which means my next hop is going to be the same thing, 192.168.0.2. So 192.168.0.2. All right, now that sets our IPv4 static routes. We'll worry about IPv6 later. Let's get IPv4 working, and then we'll worry about trying to get IPv6 working. Now, couple of questions. Number one, I know I need to write a route to get here because I want to hit this device. Do I really have to write a route to this network? Well, technically no. It will work without it. However, I tend to want to write static routes for everything. And the reason is, if this for some reason is not responding, I might try to ping this interface, which means I would have to have a route to that network in order to be able to do it. So, best practice is go ahead and write a static route for all of your intermediate routes as well, not just your ultimate destination routes. So, that's best practice. That's question number one. Question number two, can I get there yet? Well, the answer is no, because I've written a route to get to here. But this one, it's going to detect these two networks because it's directly connected, but it's not going to discover these two. So we're going to need to write static routes here as well. The other thing is, just because you have a route to someplace doesn't mean you have a route back. So even if I had a route here and a route here that would get me to this network, that wouldn't mean I'd have a route back. So I'm also going to have to write a return route. So let's come up to this way. It's best practice. Don't worry too much about that. Just go to every router and write routes for every network that they can't see automatically. And if you do that, then you should have everything covered. So let's go to R2. And for this one, I'm going to write another static route. And I'm going to start with a route to this network, 192.168.10.0. So I'm going to go to let's give us a little more room here. Go to global config mode, and it's IP route 192.168.10.0 with a subnet mask of 255.255.255.0. Now for this one, I'm coming this direction, so my next hop is going to be this interface right here, which is 192.168.0.1. All right, so that should give me a route back here. Now I'm also going to need a route to here, to this network. Now up to this point, the static routes we've written have been next hop static routes, because we're writing a static route and identifying the next hop that things need to go to. The other way to write a static route is using it's called a directly connected static route, which sounds kind of like an oxymoron. In a way it is, because if it's directly connected, I don't need a static route. So the terminology is a little bit odd. But basically what it means is, instead of specifying the next hop, I'm going to specify the exit interface. Now, directly connected static routes are not recommended on multi-point networks. So typically, if you're connecting to an Ethernet network, don't use a next hop static route. But if you're doing a serial network, let me try that again. If you're on Ethernet, do use a next hop static route. Don't use a directly connected static route. If you're on serial, that's a point-to-point connection. So for that, it works just fine to use a next hop use a directly connected static route. One of these days I'm going to get those right. So Ethernet, use next hop. Serial, you can use either next hop or directly connected or exit interface. So here's how we're going to write this. The command is the same, IP route 192.168.11.0. So IP route 192.168.11.0. the /24. Now, the difference is, for a directly connected route, also sometimes called an exit interface route, instead of specifying the next device that we're going to, we specify the interface that we're going out of. So in this case, it's going to be S000. If I was doing a next hop static route, I would write it to the IP address down here. But since I'm not, we're going to do to or out interface S00. So we put our exit interface rather than our next hop. Now you see this warning pop up. Default route without gateway, if not on a point-to-point network, may impact performance. Well, it'll say this all the time when you try to do it. We actually are on a point-to-point interface, so it's going to be just fine. We don't have to worry about that. Okay. So we've written some next hop routes. We've written a directly connected static route. The other thing we can do is we can do a fully qualified static route, which would involve both pieces. So let's see what that would look like. From R3, we need to write a couple of static routes to get to this network, 192.168.0.0/30. and 192.168.10.0/24. So from here, let's give ourselves a little more room. Get logged in, config T. And my command is IP route 192.168.0.0, and this is a /30. Now, the way you would write a fully qualified static route is to do an exit interface and then do the next hop, which in this case would be 192.168.0.5. Now there is an issue, and that is you're going to see an error when we tried to put that in. And the reason is Packet Tracer actually doesn't support fully qualified static routes. You'll see when I did the question mark here, it'll give me just the option to character return or set a distance metric, which is something we'll look at a little bit later. Packet Tracer does not support fully qualified static routes. A regular Cisco router will. So that's how you would enter it. But since Packet Tracer doesn't support it, we'll go ahead and write these as next hop or as directly connected static routes. And we'll put in both of them. 192.168.0.0 and 192.168.10.0/24. Okay. Let's troubleshoot here, or let's see if this works. Now, I'm going to start from PC1 and I'm going to try to ping over to PC2, which is at 192.168.11.10. So we're going to see if this works. We're going to go to our command prompt and we're going to ping 192.168.11.10. Now remember, in Packet Tracer, the first one will always time out. The real test is going to be the second one. And it looks like we are having an issue. So let's troubleshoot, and hey, it just took a little bit longer than I thought it should. It did start working, so never mind troubleshooting. Now, we can verify that it's going the way we want by using the trace route, or trace RT for Windows. 192.traceroute 192.168.11.10, and we can see all of the devices that it goes through to get there. All right, perfect. Everything is working exactly the way we want it to. So let's go ahead and save our configurations. Copy, run, start. On R1, go to R2. Copy, run, start. And go to R3. Copy, run, start. Okay, now let's do the same thing with IPv6. So it's going to be exactly the same principles. We just use the IPv6 command rather than, or the IPv6 route rather than IP route. We can still do them the same way, fully qualified, directly connected, or next hop. All works exactly the same way. We just use IPv6 route and we use the IPv6 addressing. The only other difference is we don't use a subnet mask. We will use a slash notation. So from R1, again, we need to do this network, 2001 DB8 CAFE1 and CAFE11. And let's do these as next hops through DB8 CAFE : 2. So here's our command. Config T, IP route, IPv6 route, I just did it, IPv6 route 2001 DB8 ACAD 1 0/64. And the /64 is what we use instead of the subnet mask. It's the standard slash notation for IPv6. And that is going to go through 2001 DB8 ACAD 2. And there's our route. Now, because that was a lot of typing, and the only difference is I'm going to 11, I'm just going to hit my up arrow. I'm going to set that to 11. And that gives me 2 next hop static routes. Let's come to here. And for this one, we're going to need to write a next hop static route to 2001 db8 CAFE:10. So, same thing, it's IPv6 route 2001 db8 ACAD 10 / 64. And it's going to go through 2001 db8 1 or ACAD 1 : which would be this device right here. So that's going to be our next stop. All right, then for the directly connected static routes, it's IPv6 route, and for this one, we're going to go to CAFE:11. So 2001 db8 ACAD 11 / 64, and because it's an exit interface route or a directly connected static route, we'll do S000. And there we go. Let's go to R3. And again, we'll write a couple of directly connected static routes. Config T IP route 2001 db8 ACAD / 64 IPv6 route. Probably help if I set the exit interface as well, S000. And then we'll do the same thing for ACAD : oops. That's going to be a problem. All right. And then let's fix this one. And I wonder how many others I did that to. Okay. So let's come back here and see if I did ACAD or CAFE. I did ACAD on all of them. All right. So I'm going to hit my up arrow a couple of times. I'm going to change this to CAFE. And then find my other one. Change it to CAFE. Force of habit will trip you up on a regular basis. And let's see what we did with R1. Yep. Sure enough. Up arrow. Change it to CAFE, both for my network ID and for my next hop. And then the same one, or the other one, make the same changes. Okay. Let's do an exit. And then I'm going to clean up my routing tables here. I think I've got everything working, but we're going to clean up our routing tables, which is great because it'll give us a chance to look at how you clear out a routing table. Let's do a show IPv6 route. And you're going to see we have, let me go ahead and maximize this. So static routes for CAFE, and the ACAD ones didn't come up. If I do a show run, you'll see that they're in here, but they didn't come up because it couldn't resolve that address. So I still need to remove them. So the way we do it in global config is we will issue the command no IPv6 route, and then we just put in the route that we want to get rid of. And let's get rid of the route to 11 as well. And there we go. We got rid of them out of there. Now, when we come over to R2, this one's going to be a little bit different. So here, if I do a show IPv6 route, you'll see that one of the ACAD ones did show up. And the reason it shows up in the routing table is because it's directly connected, so it didn't have to resolve the next hop address, so it goes ahead and shows up. But I still need to get rid of it. So it's going to be config t, no IPv6 route 2001 db8 ACAD 11. And that should get rid of that. Show IPv6 route. And we've got all those out. Okay. Let's go to R3. And we'll do the same thing. Show IPv6 route. And we'll see our ACAD networks in. And we only got one of them in before I caught it on the very last one. So, config t, no IPv6 route 2001 db8 ACAD : /64. Okay, now let's see if this works. This time we're going to start from PC2. We're going to go to our command prompt and we're going to try to ping PC1 using its IPv6 address. Ping 2001 db8 CAFE, I almost did it again, :10 : 10. And we'll get a timeout. And we'll get a timeout. And we're not getting replies yet, so it looks like we might have an issue. So let's start by pinging our side 2001. Let's start by pinging ourselves db8 : CAFE : 11 : 10. Alright, we can ping ourselves. That looks good. Let's see if we can ping our default gateway. That looks good. Now, what we want to do is we want to start pinging across here. And we want to see where we get to a break. And where we can no longer get a response, that means we may have an issue. So, go to 1 : 2, which would be this right here. And I think I just figured out what we're missing. And sure enough, we are. I forgot to do the IPv6 unicast routing command again. So, starting at R1, we got to do it on all of them. So, Cisco class, whoops, Control-Shift-6, EN class, config t, IPv6 UNI, short for unicast routing. Go to R2. Config t, IPv6 UNI, short for unicast routing. R3. Config t, IPv6 UNI for unicast routing. Now, let's see if it works. We're going to go to our command prompt. Go ahead and blow us up to full screen here, and let's do this again. Whoops. Let's go to 10 : 10. Ultimate destination. And now, one of the things you want to watch for is the reply from. We got a reply from, but we actually got a reply from somewhere else. This wasn't our destination, saying the destination host was unreachable. So we need to look and see if we can figure out why. Now this gives us a place to start looking. 2001 db8 CAFE : 1 : 1, which is going to be 2001 db8 CFA colon 1 colon 1 is going to be right here. So this was the one that said it couldn't get there. So let's come in here and type do show IPv6 route. And what we're looking for is a CAFE colon 10, and we don't see one. So we're going to do IPv6 route. Looks like we missed one. 2001 colon db8 colon AC. I did it again. CAFE colon 10 colon slash 64. And that's going to be a next hop through. So it's this router trying to get to this network, which means it's going to go through this next hop interface, which is going to be 2001 colon db8 colon CAFE colon 1 colon 1. Actually, no, I got that wrong. It's just going to be colon 1, because that is the CAFE colon. There's no 1 there. That's the 0 network. So let's add that. Now, I actually want to try to ping it from here and make sure that I can ping it from here. Then we'll go back to our PC. Ping 2001 colon db8 colon CAFE colon 10 colon 10. All right, so this router can ping there, which means we've resolved that routing problem. So now that we've resolved that routing problem, let's see if this PC can ping all the way across. And reply. All right, we are fully operational. Now, we ran into a few little difficulties there, primarily with me mistyping things, but you should see a couple of things. I wanted to go ahead and record all the way through it so you could watch as we went to troubleshoot it, because those troubleshooting things are things that you're only going to learn with practice and seeing them happen. So I like occasionally being able to let you see how I troubleshoot problems rather than wiping it out and redoing it to make sure it's perfect the first time. So you've got the file. You just watched me go through it and do it. Now, reset the devices. Just don't save your configurations. Or if you've already saved your configurations, download the file again, get yourself one without it, practice it on your own. It's a great way to learn how to do IP static routing and IPv6 static routing in a dual stack environment.